In this video, we will take a look at do some problem on Leetcode. So the problem statement is as follows. Given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. So assumption here is that we have exactly one solution and you may not use the same element twice and you can return the answer in any order. So example, the input array is like 2, 7, 11 and 15, and if target is equal to 9, then there exists this pair where 2 plus 7 is equal to 9, and hence we return indices of 2 and 7 which are 0 and 1. Example 2 is like where you have array 3, 2, 4, and when target is 6, there exists two elements whose sum is 6, which are 2 and 4, and hence we return the indices of 2 and 4, which are 1 and 2. So here the brute force approach that we can think here is, let's say you start your ith index from first element. You have to check in the remaining space whether there exists a number j such that I plus j is equal to this target. So if not, you go on incrementing j and you go till the end of the array. When such numbers where I plus j is equal to target, you will return the indices of I and j as answer. So if we take a look at source code, then we have first for loop where we start our I equal to I from 0 and go till the end of the array. We will have to start our j from I plus 1 so that we can go until this region, and we have this j less than the length of our array. And in this case, if there exists a pair of two numbers such that nums of I plus nums of j equal to target, then we will return this index of I and index of j. So if we run this program, for this input, we will get 0 and 1 because 2 plus 7 is equal to 9. So we get this 0 and 1 here. As you know, that there are two for loops here, and hence the time complexity of this approach will be O of n square. So if you see the follow-up, they are asking that whether we can come up with an algorithm that is less than O of n square time complexity. So let us go back to this answer again. So what exactly we are looking when we start our index at index of I, what we are exactly looking in this remaining space is that whether the two numbers add up to this target, or in other words, we can say that we are looking for a number where we subtract this 9, so 9 minus 2, and which gives 7, whether this number is present in the remaining space or not. And if we can store this number somewhere and we can fetch it in the time complexity of O of 1, in that case we can improve our overall time complexity of this algorithm by O of n. So in Java, basically we have hash map where the contents method will give us answer in this O of 1 time complexity. So in this approach, we go on storing the subtraction from that number from our target to our hash map. So in this case, we will as we are starting from 0th index, which is 2, we subtract 9 minus 2, which is 7, and we will store this 7 with its index of the 2 in the hash map. So our hash map will look something like 7 comma 0, and then we proceed I plus plus for the next number, which is 7. Here we will first check whether that 7 is present in the hash map or not. As the 7 is already present in the hash map, we will return this index, which is 0, and the ith, our ith index as the answer. So the source code will look something like this. We initialize our hash map. We go from 0th index to the last index of the array. If the hash map already contains the key, then we return that value of that key and our ith index. Otherwise, we will do the subtraction of that target minus nums of I, and we will store this subtraction in our hash map against ith index. So if we run this program, then this will also give the same output. But here, as the hash map, so our map dot contains key method, as the time complexity of this method is O of 1, which is constant time complexity, hence the overall time complexity of this algorithm is O of n.